All right, welcome back for day 3 of Unit 9. Today we are going to be discussing something called average rate of change. You might hear me refer to it as AROC, as you see here up in the title. It just stands for average rate of change. And actually, the rate of change of how a function changes over time is actually the exact same formula as the slope formula you learned in middle school. So y2 minus y1 over x2 minus x1. And what we're going to be doing today is comparing the different average rates of change of lines, so linear functions, quadratics, and exponentials. And we're going to kind of compare and contrast these three different types of functions. So if you look at the first table of values, or the first graph here, what you'll notice is it represents a line. This is a linear function. It is perfectly straight. And so that means that our table over here, 0 to 4, 4 to 8, 8 to 12, they are adding by the same amount. So our slope is 4. It is adding by 4. It goes up 4 over 1, up 4 over 1, up 4 over 1. That is our rise over run, rise over run. So when it's talking about average rate of change over any type of interval, okay? Oh, I failed to mention that. Average rate of change, the only difference between average rate of change and slope is the fact that they have to give you an interval. They will specifically say from this to this, find the average rate of change. If they don't give you an interval, then it's likely just a line, because this slope is never changing on a line, where it will be different for quadratics and exponentials. So sorry, I had to backtrack there. All right, so let's take a look at the first example here, from 0 to 1. So if I am going to find the average rate of change for the x values in our chart from 0 to 1, y2 minus y1 over x2 minus x1. That is going to give me 4 over 1, which is an average rate of change of 4. Okay, now let's go from 1 to 2. y2 minus y1 over x2 minus x1. And as I said, since this is a line, it should have a constant slope. So let's just, check it one more time, and then I'm just going to fill in the rest. 12 minus 8 is 4, 3 minus 2 is 1. There we go. We have a constant average rate of change because it's a line. But for our quadratic example, the reason why I knew it was quadratic is because this is not adding by the same amount. They aren't multiplying by the same amounts. But I do notice that this is a perfect square, 4 is a perfect square, 16 is a perfect square, 36 is a perfect square, 64 is a perfect, they're all perfect squares. So perfect squares are quadratics, because remember, quadratics are x to the second powers. All right, so from 0 to 1, my slope is 4 minus 0 over 1 minus 0. My average rate of change is the same, but it's going to start changing now. 16 minus 4, y2 minus y1, over x2 minus x1. There you go. All right, my average rate of change changed. It's now 12. From 2 to 3, so 36 minus 16 over 3 minus 2. That's 20 over 1, so my average rate of change is 20. Let's do one more. My average rate of change from 3 to 4, so 64 minus 36 over 4 minus 3. I'm just getting these numbers from the chart up above. Table of values up here. That's all I'm doing. And what I notice is 4, 12, 20, 28. By kind of noticing the pattern that's happening here, the next one would come out to be 36. So that average rate of change was not constant. It is increasing by adding 8. Now let's go to our third and final option. This is an exponential growth. So if I find the slope yet again, so from the first 0th to the first hour, so 4 minus 1 over 1 minus 0. So this one actually has an initial average rate of change of 3. but it's going to quickly start growing. So 16 minus 4 over 2 minus 1. All right. 64 minus 16 over 3 minus 2. 64 minus 16 is 48. So already we are well above where the quadratic ended up. And that's because this one just grows so much faster. I mean, look at the maximum of the quadratic graph, the maximum of the linear graph, and then look at the maximum of the exponential graph. So it's clearly going to be growing a lot faster. And what I notice here is to get from 3 to 12, that's multiplying by 4, 4 to 12, that's 48. So if I did the slope again, I would do 256 minus 64 over 4 minus 3, and I actually end up getting 192. I am multiplying, my average rate of change is increasing by a multiple of 4 over every one spot. So exponential functions grow substantially quicker. When we're talking about average rates of change, once we get to the top parts of these exponential growths, the line, if I kind of look at this as its own little segment, that is such a steep piece. That is why the slope, or the average rate of change, is so large. If I look like more at the beginning of that piece from 3 to 4, that little piece of the graph is not very steep at all. And that is why the slope isn't as large as it is for the next kind of hour or whatever. So we are going to be talking about how average rate of change and steepness of a line relate to each other on the next page. All right, so example 2, an astronaut drops a rock off the edge of a cliff on the moon. I don't know why on the moon, but anyways, it gives us this equation. This is not an exponential equation. This is a quadratic equation, but that is fine. It wants to know the average speed, the average rate of change between 5 and 10 seconds. There it is. Remember how they have to give you an interval. It wants to know what the average speed was from 5 seconds to 10 seconds. There are 2 different ways you can do this. Option 1, you find d of 5 and you find d of 10. Okay, so I find d of 5 and I find d of 10, so I'm going to take out my trusty calculator. Don't forget your parentheses, which some of you were forgetting on your last quiz. Well, actually, at this point now when you see this, it's going to be in the future, so never mind. Wait, why am I typing that in the y equals screen? I got to type that in the home screen. Silly me. 0.85 raised to the second power. So there's my first answer, and then 0.8, 10 raised to the second power, and that's 80. So the top one's equal to 20, the bottom one's equal to 80. Those are not my answers, by the way, because if you look at your 4 multiple choice answers, you might be like, oh, there's my answers. Those are not your answers. Remember, this is an x value. I plugged it in for x. This is another x value. I plugged it in for the x. And what I got was a y value and a y value. So my coordinates are 5, 20, 10, 80, and now I am going to do slope. y2 minus y1 over x2 minus x1. So I get 60 divided by 5, and 60 divided by 5 is 12, and that is my average rate of change. You could also, and maybe this is why I was typing in the y equals, you could have also typed in the original equation. So the original equation had an x as the base. If you type your original equation in your y equals, and you go to your table of values, find 5, boop, there it is, 20, and find 10, there it is, boop, 80. So when you have a more complicated equation, which I believe we get to maybe-ish on question 6, if and when we get there, I might use my calculator to help me figure those out as opposed to typing them in the home screen, because it's going to be a lot of filling in, whereas your table kind of does that filling in part for you. All right, number 3. Firing a piece of pottery in a kiln takes place at different temperatures for different amounts of time. The graph below shows the temperature in the kiln when firing a piece of pottery after the kiln is preheated. During which interval did the temperature show the greatest average rate of change? If you are trying to find when you're determining the greatest average rate of change, that is the steepest piece of the curve. So look at your different options. 0 to 1. So from 0 to 1. Okay, so at 0, it started with 200. So from 0 to 1 is this piece right here. From 1 to 1.5. Then we have 2.5 to 5. And then we have from 5 to 8. If we want the steepest piece to represent the greatest average rate of change, I would hope as you're coming up this curve here, you notice that it's starting to flatten out, right? When you get to 5 to 8, that's like the flattest part of the graph. That is not going to be the steepest piece. And actually, if you compare the first segment to the third section here, even this one is clearly not as steep. My rise over run is not as steep as my rise over run here. So what I'm going to do is I'm going to narrow down my options so that I don't have to do as much math. So I am not sure. I'm not sure if from 1 to 1.5 or 0 to 1 is the steepest piece of this graph. I'm not sure. So I'm going to show my work. So from 0 to 1, at 0, it was 200, and at 1, it was 700. And I'm just reading that off the graph. Now I can do slope. y2 minus y1 over x2 minus x1. And that first segment has a slope of 500. Now let's take a look at piece number 2. 1.5, or 1 comma 700, I guess, and 1.5 comma 900. So y2 minus y1 over x2 minus x1. So 200 divided by 0.5. 200 divided by 0.5 is 400. And so if I want the greatest, the first option is the winner. All right. Well, the Regents, that actually was a multiple choice on a Regents exam, so that's exactly how they look. So was number 2. Number, I don't know what happened. 2, 3, yeah, okay, we're good. Number 4 is comparing average rates of change. And this is actually where you will end up going when you get to Algebra 2. They love to compare average rates of change of different functions. So notice they are giving you 3 different functions, g, f, h. So here's g, here's f, here's h. And they are representing them in 3 different ways. G of x is an equation, f of x is a table, and h of x is a graph. It wants you to find the average rate of change from the same interval for all 3, and then tell me which one has the greatest and then which one has the smallest. So this is the one where I'm going to use my calculator. I'm going to use my calculator to figure out what g of 0 is and what g of 3 is, because that is exactly what the interval is telling me to go from. So go to your calculators. You can either type it in, which I would not suggest. Nope, I didn't want to do that. Oh no, did I X that out? Hold on. All right, sorry about that. I had to open up my calculator. All right, so I'm going to go to my y equals screen, clear that out, type in x to the second power minus 2x, and I'm going to go to my table of values. So g of 0 is 0, and g of 3 is 3. So 0, g0, 0, g3, 3. Those are my coordinate points. And now I can do slope. y2 minus y1 over x2 minus x1. So I get 3 over 3. So the slope of that one is 1. The second one in the table is actually even easier. I want to know from 0 to 3 again. So from 0 to 3. So y2 minus y1 over x2 minus x1. All right, that one has a slope of 2. And then over the same interval again from 0, so 0 up 2, to 3. So 3 up 9. So y2 minus y1 over x2 minus x1. So 7/3, which is 2.3 repeating. And it wants to know which one has the greatest. Well, h of x is the greatest because that one had the largest slope. I want to know which one's the smallest. Well, g of x is the smallest because 1 was the smallest value. I'm going to skip number 5 just for sake of time. Number 6, this is again where we're comparing these two different equations to each other. And you know what? I think I'm going to skip this last one as well, or this number 6 as well. You would just put this in your y equals screen, fill out your table. Put this in your y equals screen, fill out your table. And then you would just find the average rates of change over the given intervals. So if you want to practice that one, actually it's a really good example to practice when you compare your average rates of change over different intervals. So that'd be a really good one for you guys to practice on your own. And then number 7, let's do this one. The Jameson family kept a log of the distance they traveled during a trip, represented by the graph. Which interval was their average speed the greatest? So again, we are looking for steepest piece of our grid. From the 1st to the 2nd hour, so this piece. 2nd to the 4th hour, so this piece. 6th to the 8th, and then 8th to the 10th. Well, again, if I'm looking for the steepest section, this one is not the steepest. And even comparing this one to this one, these two are not, or from 2 to 4 is not as steep as from 1 to 2. So that's what I would recommend, is kind of narrowing down so you don't have to do as much math. And now all we have to do is slope twice as opposed to 4 times. So from the 1st to 2nd hour, y2 minus y1 over x2 minus x1. So that's going to give me a slope of 70. And if I go from the 6th to the 8th hour here, I have 350 minus 230 over 8 minus 6. And so that's going to give me an average rate of change of 60. So if I want the greatest, that's in the 1st hour. All right, I'll see you next time.